Now let us look at example 4, where we want to determine the resistance measured by our ohm meter. We have our positive terminal connected to the top of our 10 ohm resistor and our negative terminal connected to the bottom of our 10 ohm resistor. We have to recognize that our ohm meter is measuring the equivalent resistance of our circuit network. To begin, we recognize that our 60 and 30 ohm resistor exist in a parallel configuration. That is, we can say Rp is equal to 60 ohms times 30 ohms per 60 plus 30 ohms, or these two resistors exist as equivalent with a value of 20 ohms. Now if we redraw our circuit such that we replace that resistor with a 20 ohm resistor, we recognize it's in series with our original 20 ohm resistor. Thus we can calculate our series equivalent as our parallel portion, Rp, plus our 20 in series, which gives us 40 ohms. Last but not least, we recognize our 40 ohm resistor is in a parallel configuration with our original 10 ohm resistor, such that we can calculate our parallel resistance, R sub P, as 40 ohms times 10 ohms plus the quantity 40 plus 10 ohms. Or our parallel resistance is equal to 8 ohms, which is what our ohm meter is measuring.